go into logs in that chapter, I am going to review inverse for you so that you can work on your project. Okay, so hopefully you're not forgetting about the project. Remember that project is a quiz grade. I'm hoping that you do extremely well on the project. Okay, so we are going to find the inverse of this function. Now, finding the inverse of a function is back in chapter 2. So just like last week when we did the piecewise functions, inverse goes way back to chapter 2. So let's focus on this, how to find the inverse of a function. The first thing that you are going to do when you find the inverse of a function is you are going to replace f of x with y. Okay, that's the first thing that we're going to do. We're going to replace f of x with y. So I have y equals x plus 1 over x minus 2. So I have replaced f of x with y. The second thing I'm going to do is I'm going to switch my x and my y. So this y becomes x. Then I've got x plus 1, so that becomes y plus 1. Then I've got x minus 2, that becomes y minus 2. Okay, so I have switched my x and my y. So my next step, and this is where students get confused, my next step is to solve for y. And there's some pretty intense algebra here in how we solve this one for y. Okay, so this is going to be helpful for you. This is similar to the one that you have on your project. It's not exact, but it's similar. So you do want to focus on that. So the first thing that I'm going to do is I'm going to multiply both sides by y minus 2. Okay, y minus 2. What that does is it gets rid of this denominator right there. I get rid of that denominator. So on this side of the equation, I'm left with y plus 1. Now, on this side of the equation right here, what do I have to do with that x? What do I have to do with that x? Distribute. So I've got to distribute that x. So I am left with xy minus 2x. Okay? Now, students often do okay to this point. Then where it says to solve for y, they want to subtract 1 from both sides and be done. But one of the things that you've got to realize is I have a y right here and I have a y right there. So I have to get those together. I've got to get them on the same side of the equation, and then I've got to get a single y. So it's this algebra step that sometimes confuses students. So what I'm going to do now is I am going to bring this y, so I'm going to subtract y from both sides, and I am going to add 2x to both sides. Okay? So what I have done there is I have gotten my y's on one side of the equation, and I've gotten everything else on the other side of the equation. Okay? So I'm left with xy minus y equals 2x plus 1, because this cancels and that cancels. Okay? This right here is where students get confused and they don't know what to do next. That part of it. If you get to this part, then you are probably okay. Okay? So, I am going to take this equation and I'm moving it right up here. So I have xy minus y equals 2x plus 1. Okay? Now, I have to get the y completely by itself. So I've got to use the distributive property in order to do that. So I am pulling the y out. And when I pull the y out, what am I left with? Y times what gives me x times y? Good. Y times -1 gives me y. Okay? Now, what do I do to get y by itself? You got it. Okay? So my answer is y equals 2x plus 1 divided by x minus 1. Actually, I've got one more step. Does anybody know what the last step is? Do you remember from chapter 2? Yes. Excellent. Replace y with f inverse of x. Okay? So my actual final answer is f inverse of x, and I am totally running out of room, 2x plus 1 over x minus 1. So that is my final answer right there. Okay? Now I know we did that back in chapter 2. You can definitely talk to each other. You can definitely watch this video. I'm recording this, so I'll post it on Canvas, and I'll go ahead and pull the piecewise function and put it up there too. Now, you're asked to do a bunch of stuff with this. If you look at your project, you are asked to do a ton with this inverse function. This is the hard part. Once you get this, you're in good shape. Now, I want you to, the next thing that you're going to do is you are going to graph it. Okay? You are going to graph it. This right here was your original function. This is your original. Okay? So look at how I typed that into Desmos. And remember, you can use Desmos on all this. Here is my original function, f of x equals x plus 1 over x minus 2. What is different here? What's different? The parentheses. Okay? When you type this in, you've got to make sure it looks like that. This is my inverse function. That's my inverse right here. Okay? Do you see how I have parentheses over the numerator and the denominator when I type it into Desmos? That's important. Okay? Desmos only does what we tell it to do. You don't have to include this, but you certainly can. This is called our identity line. I just did it so that you could see it. So you don't have to do that. Okay? Here is what this looks like. And you are going to have to sketch this. You're going to have to sketch this. This is, you are graphing both of the functions on the same graph. You're graphing the original function and the inverse function on the same graph. And do you see how these cross right here at the identity line? That's how you know you did it right. That's how you know you did it right. Okay? You are looking for this x at the identity line. Okay? Now, and you're going to sketch that. So, and I know it won't be perfect because you're sketching it, but use Desmos and then sketch it. Yes, ma'am?
Do we have to, when we graph, are we putting the identity?
You don't have to. It's really kind of your call. If you want to, you can. You don't have to. A lot of times I do on Desmos just to make sure I'm correct. Like if it looks, now it may look different than this, but it's going to cross. Like this intersection right here, you are going to have the two graphs crossing on the identity line, and that's your indication you did it right. Okay? Now, the other thing that may be confusing is when you are asked to find the domain and the range of the original function, and we know that this one is the original function because this says f of x. This is the inverse function. Why? What does this have? What's the difference between the f of x at the top and then good, and that's read f inverse of x. F inverse of x. So, when you are asked to find the domain and the range, what you need to do is find domain for both. That's what you need to do. You've got to find the domain for my original function and find the domain for the inverse function. And if we go back and look, okay, the original function is purple, I guess. It looks red up there, but it's purple. F of x equals x plus 1 over x minus 2. How do I determine the range of that? What can x not be? Where can we not have a 0? The denominator, okay? So I've got x minus 1 right here. So for my original function, x minus 1 cannot, was it x minus 1 or x minus 2? X minus 2. So this is my original function. I've got x minus 2 in the denominator. X minus 2 cannot be 0. So how do I write that in interval notation? How do I write x minus 2 cannot be 0? What can x not be? X cannot be 2. Okay? How do I write x cannot be 2 in interval notation? Okay, you said negative infinity to what? 2. Good. You got it. Okay? Now, here, where's my end? So I've got x minus 1 in the denominator. Do you see that? X minus 1. So I cannot have a 0 there. So for my inverse function, for my domain of my inverse function, I cannot have x minus 1 cannot be 0. So what can x not be? 1, positive 1. Okay? So I would write that negative infinity to positive 1, 1 to infinity. Now, the domain of your inverse function is what? It is, okay? The domain of your inverse function is the range of your original. Okay? So don't let that confuse you. The domain of your inverse is the range of your original. The domain of your original is what? Your range of your inverse. So that is how you find your domain and your range. Now, can I move off the screen? I still see people writing. The domain of your original is the range of your inverse. The domain of your inverse is the range of your original. Okay. Now, number 3 and 4 are piecewise functions. We went over those last week. I did a video over it. Is this number 5, I think? Oh, no. Number 5, I'm going to give you hints in just a minute. If I had to guess, you're making number 5 harder than it is. Number 7 is what we just did. It's an inverse function. Number 7 is what we just did. Okay? Number 8 is exponential. We did that in class on Thursday. So you should be able to do number 8. Okay? I'm not going to review it because we've just done it. So number 8, you should be able to look at your notes from class on Tuesday, and you should be able to do that one. Okay? Number 9 we'll do this Thursday. Number 10 is matrices. We did that all before spring break. You can use the app, the Matrix app that we used before spring break. Extra credit is also related to that because it's extra credit. I'm going to give you minimum information about the extra credit, but look at your notes before spring break. Now I'm going to come back to number 6. Number 5, don't make it harder than it is. Don't make it harder than it is. Okay? My hint to you, write down the ordered pair of the shaded dot. Write down the ordered pair of the shaded dot. Then focus on the definition of domain and range. Focus on what you know about domain and range. Okay? It'll be one of those moments that you're like, oh, really? Could it be that easy? So don't make it harder than it is. Okay? Now, I want to talk about number 6. Number 6 is probably the more challenging of it. I got advice from a colleague of mine in Denver, and she always said there needs to be one question on your test every single time, Alicia, that only an A student will get. Okay? Number 6 is that question. Number 6 is that question. Okay? So I'm not going to give you any more information about number 6. I'm not going to do an example like number 6, and you really haven't seen number 6. So these are the number 6 hints. Use your vertex formula. Okay, so that's f of x equals a times x minus h squared plus k. You are going to create a vertex formula without your a value in it. Okay, just leave a as a. Okay, you don't know what a is. You don't have enough information to determine what a is. So just do your vertex formula with the a. Then plug in that second point to your x and your f of x to figure out what a is. So it's almost like the idea that you want to think about here is, do you know how if you're given 2 points of a line, you're able to get your linear equation? If I give you 2 points on a quadratic, you're able to get your quadratic formula or your quadratic equation. But you're going to have to think. Okay? This is one of those that you don't look at it at 8 o'clock the night before it's due. You need to look at it today, then you need to look at it on Saturday, then you need to talk to somebody in class about it, and then you need to think about it again. So this is the one that you're going to have to revisit over and over. Okay? I think that's it. Yep, that's it. Those. Now, I'm going to do a review on numbers 1 and 2. Okay, and then I think we will have everything. 1, 2, 3, 4, 5, 6, 7, 8. Oh, and 9 I'll lecture on Thursday. So on Thursday, you'll have all the information you need to go back and make sure you've can finish so you could finish the project this weekend. You will have the information to finish the project this weekend. And I would encourage you to go and do that before things get too hectic. I'll take it and I'll put your grade in whenever. Okay? Questions about your project? When is your project due? When is your project due? The day of the final exam. Okay? So your project is due the day of your final exam. What kind of grade is your project? Nope. Test grade. Your project is a test grade. So if you've got a test that you want to drop, and we all have a test we want to drop, right? Okay? Then you make sure you do a bang-up job on this. There's no reason you can't have at least a 90 on this. At least a 90. Many of you will get the extra credit. Some of you will get number 6.
So if we say, okay, I know you already say that the final test, or like your lowest test grade gets dropped. If you may battle, like say 2 tests, you could replace it with.
You can't drop both of them, and you can't replace it with anything. Okay? I will drop the one that helps you the most. Okay? I'll drop the one that helps you the most, which is typically your lowest one. In rare, I can't think, like when I used to do it with your final exam, would replace your lowest test grade. I would tell students I would only do it if it benefited them, but dropping your lowest, I think, always benefits you, typically. So, but I can certainly look into that. Just to, I don't want to do it if it doesn't benefit you. So, any other questions about your final exam? Okay.